Hi, this is Aaron with Northwest RepRap, and today I'm going to show you how to connect the ramps electronics to your RepRap. And instead of using a RepRap, I'm going to demonstrate this using our testing station. We test every set of electronics that we ship out, and because nothing is more frustrating than starting a new hobby and working with equipment that's failing on you. So we always make sure that everything is fully functional before we ship it out. And we do that with our testing station here. We have 4 stepper motors for the extruder, X, Y, and Z axis. The RepRap technically has 2 motors for the Z axis, but for testing only 1 motor is really necessary. We have a power supply. We have 3 LEDs which represent the heat bed, hot end, and fan. We have 2 thermistors here on the electronics, and then we have 3 end stop switches. So that's what we use to fully test the electronics. And so let's go over a little bit the electronics, show you what some of the components here. On the electronics themselves, there is the Arduino Mega 2560 in the back, and then this green board in the front is the actual ramps. And then on top of the ramps you have 4 stepper drivers by Pololu, and on each of the stepper drivers you have a potentiometer which controls the amperage output for the stepper motors. So there's one there, there, and there. And I'll talk about adjusting those a little bit later. But if the amperage is set too low for a stepper motor, the motor either won't work or it'll act kind of jittery. It can act kind of jittery if the amperage is too high as well. And then it can also actually overheat the stepper driver or overheat the motor if the amperage is too high. And these circuit boards have built-in protection, so if these chips do overheat, they automatically shut off, and you actually have to disconnect the power to the electronics and let them cool before you can operate them again. Okay, also on the electronics you have the power input terminal block, which is right here, and on the ramps electronics is actually labeled positive, negative, and so you will want to hook it up that way. So as in with this terminal block here, we have red wire for positive, black for negative, red for positive, black for negative. This is a 12-volt input. And then you also have these terminal blocks here. D10 is for the hot end, D9 is for the fan, and D8 is for the heat bed. Okay, now first I'm going to start with, oh, by the way, the LEDs and end stop switches and thermistors actually channel underneath the board and come out with these to these ribbon cables here. These are the thermistors, these are the end stop switches, and over here these are the hot end, fan, and heat bed. So I will go ahead and connect the thermistors first. Thermistors are connected right here on these pins here, and it's actually labeled on the electronics as T0 and T1. So the hot end thermistor will get connected to the first 2 pins, and then the heat bed thermistor will get connected to the second 2 pins. So the hot end goes to T0 and the heat bed goes to T1. Now when you connect your thermistors, you'll be using a 2-way computer socket connection. We use a 4-way just because it's a little bit faster to plug that in for testing. Next I'll connect the end stop switches, and I have these set up for the X-axis, Y-axis, and then Z-axis, and these will get plugged in up here. These first 2 sets of pins will be for the X, and then you'll skip a set of pins, and the third set of pins here will be for the Y, and then you'll skip a set of pins, and this set of pins here will be for the Z axis. And this is labeled on the electronics underneath here. And you'll use 3-way computer socket connections for these. So you can see it's connected here for the first set, and there's an empty set of pins, and it's connected, then an empty set, and then it's connected there. Okay, next I will connect the hot end, which will go into D10 here. and then the fan will get connected to D9. Now these connections here that I'm using on these terminal blocks are actually spring loaded, and we just use these because it's a little bit faster to go through the testing procedure. But when you connect your wires to these terminal blocks, you'll actually just insert bare wire. And if you wanted to, you could actually coat the wires with a little bit of solder too, and let it dry first before you connect it. And normally once you insert these wires, then you'll tighten them down by tightening these screws. Also, be sure that whenever you unplug or plug something into the electronics, you'll want to make sure that the USB cable is not connected and that the power supply does not have power turned on. Okay. Okay. Next, let's connect all the stepper motors. The Z-axis stepper motor will get connected here next to the Z-axis stepper driver, and then the Y-axis will get connected here. Okay, and then the X-axis, and then the extruder. So on the RepRap Prusa i2, you'll actually want to make sure that when these are plugged in, they're plugged in blue, yellow, green, and then red from left to right, like so. Except for the Z-axis, and I actually plugged this one in upside down. This one will actually go in the opposite direction. Red, green, yellow, blue. Technically for the testing workbench it doesn't matter, but in your case it will. Okay, now I have the power supply turned off, so I can go ahead and plug this in now. You don't want to plug it in while the power supply is powered on. Okay, and now that I have everything connected, I can go ahead and plug in the USB cable now. All right, so that takes care of the wiring. It's pretty straightforward. I'm going to use a ceramic screwdriver just to tighten this down a little bit because it just slipped out. But please be careful when connecting these, because it's very easy to short out the electronics. Also, the power input doesn't have any protection, so if you did connect it with the polarity reversed, you could fry the ramp's electronics. So be very careful with that. And also, these stepper drivers are also very sensitive. You never want to use any metal screwdrivers when adjusting the potentiometers or for any other reason while the USB cable and the power input is connected. It's very easy to torch the electronics. Okay, now I'm going to go over to the computer and show you how to do some of the software, or how to set up the software for the electronics. So first of all, when you first connect the USB, it's likely going to come up as an unknown device here in Windows 7. So in order to install the software, what you'll need to do is open up the unknown device and click on Update Driver. You'll want to browse My Computer and then Let Me Pick. And then you'll want to show all devices here. Click Next. And then also, by the way, you can download all of the software that you need from the Northwest RepRap website for this, okay? At this screen, you'll want to click Have Disk. And this is where we'll want to browse to the Arduino directory. And I have this on a thumb drive. And when you download the Arduino software from the website, it will be the 0022 version, which is what I recommend for now. You can always try a different version later, but just to make sure that things are consistent and that you're able to get things up and running, it'd be best to work with something that's stable. So 022, And then under 022, there's a directory called drivers. And then under drivers, there's an info file for Arduino Mega 2560. So you'll want to select that and open it. And then click OK. And here it is, Arduino Mega 2560. Click Next. And it may ask you if you're sure that you want to install the software. Just say yes to this one. Okay, and then it should finish installing the software, so you can close that. And then if you look at the properties for this driver, it should show you Arduino Mega 2560 and the COM port for which it's installed. In this case, it's installed to COM 27. And you'll need to know this later on. Okay, so that takes care of the driver installation. And for you, it might actually be a little bit easier. I mean, it might even auto-detect it and install it automatically. But in most cases, from what I found on Windows 7, is that you do have to install it manually, just like I showed you. Okay, so once that's installed, the next thing that you'll want to do is upload the firmware. And you can download the firmware from our website and open it into the Arduino software. And then under Tools, you'll need to change the board to Arduino Mega 2560, which is already selected here. And you'll need to change the serial port to COM 27. And under the configuration H file, this is primarily, unless you want to get more advanced, this is the only configuration file that you'll need to modify for the electronics. And at first, you really don't need to modify it at all, actually. So go ahead and click File, and then Upload to the I/O board. And down here at the bottom, it will say that it is uploading. And now we'll just need to wait until it's done. Now, if you don't have a ceramic screwdriver like this one for adjusting the potentiometers, you could also use a plastic screwdriver or maybe a wooden screwdriver. I've been able to make wooden screwdrivers out of barbecue skewers, which will work just great. Okay, so it says done uploading right here in this green bar. So now we can move on to Pronterface. And so let me move the camera. Okay. All right. Okay. Now in Pronterface, you'll need to change the COM port to COM 27 and the baud rate to 250,000 and click Connect. And you know that it's connected because it doesn't say that it failed here in the console, and also all the controls just lit up. So we know we're connected to the electronics now. So I'm going to go ahead and plug in the power supply now, and that will give power to the stepper motors and to the hot end, heat bed, and fan. And now I'm going to go ahead and just go through some testing and some adjusting. The first thing that I start with is the x-axis. So I can see by hitting the x-axis home button here that it did move the x-axis motor. So I'm going to show you over here now how to adjust that stepper driver for the x-axis. Okay, so I'm going to hit that home button again. Now, this is the x-axis stepper driver here, so I'm going to need to adjust this potentiometer. So I could hear some whining, which means that it was set up, the amperage was a little high, so I just turned it down a little bit to get rid of that whining sound. Now I'm going to hit the X-axis home button again, and while it's homing, I'm going to adjust the potentiometer until it's quiet and at its lowest amperage possible. So if I turn it all the way to the left, notice how the stepper motor starts to slow down quite a bit. That means it's set too low. So just turn it up a little bit from that point, and now it's at its ideal movement. Okay, it's nice and quiet, and it spins like normal. Okay, that means that is set perfect now. Okay, and then I can move to the Y-axis. So I'll hit the Y-axis home button, move my ceramic screwdriver to the Y potentiometer, turn it down until it stops moving, and then turn it up just a little bit until it's moving smoothly. And now I'll do the same for the Z-axis. So turn it till it stops moving, turn it up a little bit until it's moving, and that's perfect. And now I will do the extruder motor, which is the top one here. Turn it till it stops moving. Excuse me. Okay, and then turn it up just a little bit from there. And then that's perfect. Okay, so it's nice and quiet, it moves smoothly, it doesn't jitter. That's exactly what you want. So you want these set at the minimum amount of amperage necessary for proper operation. Okay, next it's best to test the end stops to make sure that they're connected and working properly. So I'm going to hit the X. So I'm going to hit the X home again, and while it's moving I'm going to hit the X end stop to make sure that it stops the motor. And it did. So I'll do the Y next. Okay, it stopped. And then the Z. Perfect. All the end stops are working properly. Excellent. Okay. Next, I will test the thermistors. And to do that in Pronterface, move it over here. What you need to do is click on the Monitor Printer checkbox at the top here. And down here in the heater and bed section, it should show a change in temperature. It went from 0 to 21 Celsius for the heater, and it went to 21 Celsius for the bed, which is perfect. And I could even put my thumb on these thermistors to make sure that they heat up, and I'll do that right now. So I put my thumb on the thermistors, and I can see the temperature is increasing to about 28 degrees Celsius. So those thermistors are spot on. Alright, and next I'll want to test the hot end output, the heat bed output, and the fan output. And to do that, I'll just set the temperature for the heater, for the heat bed, and then I will also turn on the fan by sending command M106. And as you can see, the LEDs have turned on for the hot end, heat bed, and fan. So I know that all three of those outputs are functioning correctly. And I also know that this set of electronics is perfectly functional. Everything checks off and everything's working properly. So I can go ahead and set the fan to off by sending the command M107. I can shut off the heat bed and the hot end. And I can also disconnect the motors, disconnect from Pronterface, and now it's safe to power off. And unplug the USB. These are ready to be packed up and shipped out. And if you were following along while you have this connected to your RepRap, you know that that it's fully functional and you can move on to calibration. So I hope that this was informative. If you have any questions, please use our contact form on our website, or you can send me an email directly to Aaron at nwreprap.com. Thanks for watching. Have fun.